Hello and welcome to Completing the Square Day 1. Today your goal is to convert from general form to vertex form by a method that we call completing the square. So please take out a notebook or you can grab a whiteboard to complete the problems. Please make sure you're doing them, as I will not reteach this tomorrow, so make sure that you get all the information you need down. You can rewatch the video as needed, but please again make sure either taking notes or writing out the work on a whiteboard so that you're practicing. So first we need to identify what perfect squares are, and you already know all of these, but just to refresh your memory, it's a number that is squared to get the answer. So like 1 squared is 1, 2 squared is 4, so that means 4 is what we call a perfect square because 2 times 2 gives us 4, and so forth. So again, you know a lot of these, and we could keep writing them on forever. I am going to expect that you know at least up through 15. So 81. So most people are good through 10. I always forget 14 squared, so it's just the opposite of 13, so you just switch the numbers in place. And then 15 squared is 225. Right, so those are what we call perfect squares, and we need to know those because we're going to be creating perfect squares, right? So first, let's refresh our memory on how we can get this FOILed or multiplied out. So x plus 4 squared is really x, and you practiced this last time. So that's going to be x squared, 4x, 16. So x squared, and remember we add the middle, plus 8x plus 16. So go ahead and do the next one on your own, since I know you can do these from last unit. So that one we get x squared plus 6x plus 9. All right, so then we want to look at kind of a pattern here. I noticed that 4 plus 4 is 8. And I noticed that 4 times 4 is 16. So see if that works for the next one. Right, so I noticed that 3 plus 3 is 6. And 3 times 3 is 9. So using what I know now, I'm going to see if I can write the x plus 7 squared out without having to use a box. So I'm going to look, that means 4 plus 4 is 8. So I'm going to do 7 plus 7 is 14. And then I did 4 times 4 is 16. So 7 times 7 is 49. So that would be the quick way to multiply that out. So go ahead and see if you can write the last one without using a box. So this would be x squared minus 8x plus 16. So this is what we would call a perfect square as well, because it's squared and we multiplied it out. Our goal is to get all of our equations to look like the x minus 4 squared. All right, so now we're going to work backwards. I gave you the answer. See if you can figure out what the perfect square was. So 10 and 25, the number I think of is 5, because 10 is 5 plus 5, and 25 is 5 times 5. So 6, it's 3, because 3 plus 3 is 6, 3 times 3 is 9, and 8 is 4, because 4 plus 4 is 8, 4 times 4 is 16. All right, so now I'm going to take away all that and just give you one number, and you are going to have to complete the square is what we call. So completing the square means you have to figure out, okay, so 14 is what I added to. So 7 plus 7 is 14. What number would have to go here then to make sure that it's actually 7? Well, that's 7 times 7, which is 49. So really the way I explain it then is you take half of the middle term, so half of 12 is 6, and then you square 6, so 6 squared is 36. All right, so that's the full step, is completing the square. Our goal is to utilize this to write in vertex form, because if you notice, vertex form looks like this. And notice that it always has that component of that perfect square in there. All right? So this is what you're going to be asked to do on your worksheet now, is convert from general form to vertex form by using this method we just learned called completing the square. So step 1, you write x squared plus 6x plus blank, because 11 is not the number that makes 6 a perfect square here. All right? We keep that 11 on the end, And we're going to be adding a number here. In order for the equation to stay the same then, we also need to subtract that same number because that needs to balance it out so that we're not actually changing the equation. And we know that we want to get it into something that's a perfect square, so we're going to put x squared below. And we just follow that pattern. Half of 6 is 3. 3 squared is 9. If I add 9, I also need to subtract 9. And negative 11 minus 9 is negative 20. And with the swish of my pen there, I now have an equation that looks like vertex form. Right? And I can use that equation now to say that the vertex is negative 3, negative 20. And remember, I have to make the inside number negative. I just wrote that in the wrong spot though, so hold on, let me fix that. Nope. All right, and now we can go ahead and write the y-intercept. The y-intercept we can tell from just looking at the original general form here. Remember, it's the last number, so that is 0, negative 11. If I wanted to make a quick sketch, I would just go left 3, down 20. And again, it's a sketch, so we don't need to draw 20 dashes. We can just approximate. And the y-intercept is at negative 11. That's half my parabola, but remember the axis of symmetry always goes through the vertex. So I have another point over here that matches with the negative 11. All right, so go ahead and pause the video and see if you can follow the same steps. All right, step 1. Put a blank in because 30 is not the number that works, but 30 still has to hang out because I can't change the equation. And I need to minus the same number I'm adding. So these two spots should always match. And then I know that because I want it to be in vertex form, I need a parenthesis squared here. So now to get what goes in there, I'm going to do half of negative 12, which is negative 6. And 6 squared is 36. If I add 36, I also need to subtract 36, and 30 minus 36 is negative 6. And I now have an equation in vertex form. All right, so I can go to my questions now. The y-intercept comes from general form. That's 30. The vertex comes from vertex form, and there's our vertex. Remember the inside number, we switch the sign, so it's positive 6, negative 6. To graph, I just go right 6, down 6. Again, it doesn't need to be perfect. And then my y-intercept is way up here at 30. Remember, the axis of symmetry goes through my vertex, so I always have a matching point. And there's my nice parabola. All right. So that's it for the video for today. You can watch it if you need another example again. Please make sure you fill out your recipe card with the steps. Check in with your neighbor if you need help, or rewind the video for the steps. Complete worksheet 1 in your packet. You can choose either skills or core extension. And then I do have the answer keys done, and they are posted on Google Classroom, so please make sure to check your answers when done. Otherwise, have a wonderful night.